So in the last class we have discussed about p-type semiconductor. Today we are going to discuss about n-type semiconductor. So the n-type semiconductor is going to be formed by adding pentavalent impurity atoms to the intrinsic semiconductor. So the pentavalent impurity atoms is going to have 5 valence electrons and the intrinsic semiconductor is having 4 valence electrons. That means the examples of pentavalent impurity atoms are arsenic, antimony, phosphorus. So this arsenic, antimony and phosphorus is having 5 valence electrons in its outermost orbit. So whenever this arsenic is going to be making covalent bonding with 4 valence electrons, that is intrinsic semiconductor, each arsenic 4 valence electrons is going to be make covalent bond with the remaining silicon atoms. But as the arsenic is having an extra free electron is going to be generated. Why? Because it is not going to be covalent bond with the intrinsic atoms. Why? Because the intrinsic atoms is already shared these 4 valence electrons with the arsenic atom. So the remaining electron, that is called as an extra electron or free electron. So a free electron is going to be generated by adding each and every arsenic atom to the intrinsic semiconductor, so that an extra electron called free electron is going to be generated whenever we are going to add pentavalent impurity atoms to the intrinsic semiconductor, so that a donor energy level is going to be created nearer to the conduction band in n-type semiconductor. Similarly, we are having a valence band, that is acceptor energy level is going to be formed nearer to the valence band in p-type semiconductor. We are going to have donor energy level which is going to be created nearer to the conduction band in n-type semiconductor. And at absolute 0 Kelvin, the n-type semiconductor is going to have an extra electron, so that it is not going to conduct any current at absolute 0. But whenever the temperature increases, the electrons start to flow. That means even though it is going to have an extra electron in n-type semiconductor, but the current is not going to be formed only at absolute 0. But when the temperature is going to be increases, then this electron starts to conduct. Or if we are going to apply any electric field to the n-type semiconductor, then the electron starts to flow and the current is going to be formed. That means what we are going to understand from the basics of this semiconductor, in the sense, even though the p-type and n-type semiconductors is going to have an extra electron in p-type semiconductor or an extra hole in p-type semiconductor or an extra electron in n-type semiconductors, these holes and electrons will not going to form the current until unless if we are going to apply an external supply voltage, or if we are going to increase the temperature. That means at absolute 0 Kelvin, or if we are not going to give any external supply voltage, the current is not going to conduct in p-type or n-type semiconductor. Only when we are going to increase the temperature to room temperature or more than that, or if we are going to apply certain voltage to the p-type or n-type semiconductor, then only the current is going to start, or the current is going to conduct.